Hi, I'm Lauren Walker. I'm a software developer for the Arctic Data Center, and today I'm going to talk to you about the Permafrost Discovery Gateway. I'm going to show you what the project is and some of the data visualizations that we're working on. So through the permafrost carbon feedback cycle, it's clear that permafrost is a critical feature of the Arctic, and we don't yet fully understand it. So there's this need for tools that enable us to research the thawing permafrost, and the Permafrost Discovery Gateway is looking to fill in that gap. So one example of the type of data the gateway has focused on is detecting the extent and change of ice wedge polygons across the Arctic. So as water in the permafrost freezes and thaws over years and years, the soil cracks and buckles, and it creates these ice wedge polygons. And you can see in this photo on the right that they're pretty visible from the air. So just like big data, the gateway is analyzing big imagery from global satellites that take photos of these ice wedge polygons. And we're using machine learning to detect them at a super fine sub-meter resolution. When complete, the Permafrost Discovery Gateway will provide an interactive web-based visualization tool for researchers to explore and access the permafrost data and maps. This will include temporal animations, a plot viewer, and the high resolution imagery viewer that's shown here. So this was a screenshot that was just taken yesterday of the development that we've done so far, and the data set that's shown there is a permafrost zone data set. So the data sets are being produced by our collaborators and the community. So for example, Shandi and Rajita here are building machine learning classifiers for mapping ice wedge polygons across the global Arctic in their project Maple. So we start out with this commercial satellite imagery shown here on the image on the left. And if you zoom way in, you can actually detect the ice wedge polygons and the troughs around them. And we can detect whether they're high or low centered polygons. The algorithm used to detect ice wedge polygons is a convolutional neural network, CNN, and it's the same type of algorithm that's used to detect everyday objects like your fridge or microwave. It's fed training data of the ice wedge polygons, and now it can detect the polygons automatically. So this model is just going to be applied over and over and over again all across the Arctic. For now, here's a section that's done of the North Slope of Alaska. So once we have hundreds of terabytes of polygon vectors from the modeling application, we then need to process that into a little compact way that will be able to show it in your browser like Firefox or Chrome. And one of the tools that we're using to do this is we're extending a Python library called Py3D tiles to take all of that terabytes of vector data and tile it out so that it can be shown in Cesium, the mapping platform there. The resulting web user interface will let researchers zoom into areas of interest and see the ice wedge polygon vectors. You can overlay it with other data layers of interest, control visibility of layers, the opacity, colors, even filter out data based on certain attributes. And you can export the maps that you've created and just use them in publications. You can zoom all the way into individual polygons, even though these data sets are global in coverage. This is a really extensive project. And as the gateway matures, we will continue adding additional data layers such as the permafrost zonation map. Users can explore the features of these data layers by clicking on them, overlay other data, and eventually even import your own data into the system. The gateway will provide powerful visualization and exploration features that support scientific understanding of the Arctic systems. And the system will be fully open source. We encourage folks to use it, contribute to it, and join us in building it. I'd like to acknowledge my co-authors, especially Robyn for her work on the visualization UI, the Permafrost collaborators, including Anna, who leads it, Shandi, who leads the ice wedge polygon work, and all the other collaborators working on the software. And with that, I'll take any questions. Thank you.